Hey, welcome to the Mentorboard Engineer. In this video, we're going to talk about this machine that I picked up for $2 at our local thrift store. Now, I have no idea what this is when I bought it, but I was like, man, there's some cool mechanisms in here, and I want to show people all about it. Hey, if you like what you see so far, please be sure to smash that like button and subscribe and click that notification bell so I can annoy you at least once a week. So it wasn't until I got home that I looked it up on the internet and found out that it's a cigarette machine. But it would have been a lot easier for me to figure that out if I just read it right down here where it says cigarette machine. Man, what are you gonna do? So once I figured out what it wasn't too hard to figure out how it worked. So the first thing was you're going to put your cigarette tube right here on this tube sticking out, and it's going to get clamped by this little rubber piece, and then you'll put your tobacco right in this hole right here, and then you'll take your lever and three things will happen. It's actually pretty cool. The first thing is that this rubber will clamp against the cigarette tube so it doesn't pop off. It'll shut this door right here, and then the last part of the action is it will shove out this metal piece right here into the cigarette and leave the tobacco in there and then retract. Now, interestingly enough, this metal piece right here has teeth on it, so that if I were to go this way, it would really, cut my finger. It's pretty sharp actually. But if I go the other, when I pull it back, it's gonna leave the tobacco in the cigarette. Now, if you think about like a push saw, when I push that saw in, it's going to cut, but when I pull it back, it just kind of is along for the ride. Doesn't do anything. So let's dive deeper into the mechanism here on the back. All right, so let's get into our Top-O-Matic T2, the world's toughest cigarette machine. All right, so let's look at that action up close. You can see here that there's the rubber stopper that's gonna hold the cigarette tube, and we got a door right here, and we can start activating it. You can see it closing on my finger. Oh no, it's gotta get off. All right, and then we can see when we get to about 45 degrees here, it pushes all that tobacco in there. Now imagine that this handle is here so that you don't cut yourself on that thing as it comes out. We'll see how that goes. All right, so simple here. We have a rotary mechanism activating the 1, 2, and 3 things. And we start up here at about, let's say it's 30 degrees from the vertical. And we have the two actions to about 45 degrees. And then about another, not quite 20 degrees there. So almost 180 degrees of articulation here. So we'll flip it over and see what's going on. So we'll start over here, and we see that we have a rotary cam device right here, and it looks like not all the things are attached to this center part right here. So the first thing we have is we are attached to this bar right here, and this bar slides, and we'll get to why it slides in a minute, in this channel right here. All right, if we take this right here, let's ignore all this right here. We have a series of parallel links. So this is one link going right here, another link right here, and as long as we move, this part will always stay parallel to that part. All right, you can see that there. Now what we really want to do, the action, is to open and close this door square on. So we have another set of parallel links where this is the link, and this is the same link as before, and these two links here will keep it parallel, and actually keeps it, if they're all the same links right here, it'll keep these two always moving vertical. So that's how that door opens and shuts. And that's pretty ingenious if you ask me. Man, that's cool. That's the first action. Now this cam works. You'll notice that as it moves past that into the next phase, I've stopped rolling this on this edge here, and now I've got this mechanism that pushes over. Now as it goes, this will go with it, but it won't change the position of this linkage until I release, and then I pull back, and there it is. Then I can reset all the way. All right, so that's this mechanism, and that's fairly clever. I mean, anytime you can do things without using electronics in the mechanical world, it always fascinates me. So right here, let's look at this. We want to hold our cigarette here, and when we're all the way back open here, we have this little dog leg. Maybe you can see it right here. Little tab sticking up that was formed out of the link, and it's only formed on that one, that actually pushes this cam member open right here. So you can see they're contacting, and then as I start moving, this will rotate out of the way just a little bit so that the rubber stopper here is now touching this. And as I pull it away, those parallel links will force it apart just a little bit. So it's only this very small spring that's holding the cigarette on this tube. If it were too much of a spring and it really didn't have any give, we might actually tear the cigarette tube off. So let's talk about this last action. This right here is the rod that has all the tobacco in it, and it pushes out. And it's basically just a rod that slides in this channel right here with this piece right here. There's a little bracket back there that allows us to move over and just pull that around. This is a lever arm here, and this is a cam right here. It's a short lever as well. Just pushing that right on in. So the real question is, why doesn't this activate at the same time that this activates? How do we keep those in sequence? So the answer is quite simple, is this lever arm is not directly connected to the handle that we rotate. What's directly connected to it is this cam plate that we saw before. Has this rotation here that allows this thing to move. So what happens is this lever isn't attached, and it doesn't move until the cam that's attached to the handle right here, that little tab will push against right there. And you can see it go. See, I've fully stroked this part now. Oops. I've fully stroked over here, and now this will push and it'll activate this cam. All right, and the spring will pull it back to its original position. So the only thing left is, what does this tab do right here? And that tab stops all the action. That's what prevents this handle from going continuously around this way. Once it hits this lever right there, it'll push against this, which pushes against the back part here, and that's why it's got these two tabs that are bent up. So it'll push and not make a dent over here over time. So very simple application. Now, a couple things I am curious about. Now, this is a food apparatus. I wouldn't want to have any grease in here, and I'm touching some of these parts, especially right here, and it feels like there's grease on it. So I hope that's food grade grease. I don't know about you, but I don't want grease in my food, no matter what the qualifications are. And the other thing here is this right here is made of rubber, and then I've got stainless steel right next to it. But how do you clean that once you get oils on your finger? Just overall cleanliness of this is some cause for alarm. I mean, I'm not saying there's anything bad with it, but it's stainless steel, and over the years it's started to rust a little bit right here. So just how do you clean this, I guess, is one big thing. But other than that, it's a fascinating machine. I mean, that's just a lot of engineering went into that. And hey, so thank you for watching this episode of The Mentored Engineer. I had fun explaining to you how this works, and just the various levels of cool mechanisms that you can find in old machinery like this. So thank you for watching this episode of The Mentored Engineer. If you liked what you saw, please take a second to like, share, and subscribe, and we pass it on to your friends. Thank you very much.